Recently, I discovered Microsoft Rewards. Basically, you complete short tasks using Bing Search to earn rewards points, which you can then use to redeem rewards like gift cards. It's practically worthless. Yeah, that's gonna be like 3 weeks of searching. So I was ready to quit, but I thought to myself, if I can automate it, then it would require no extra effort from me, and I could collect the same rewards regardless. This is against the terms of service though, so don't tell Microsoft. The idea is to automate all the browser tasks using Selenium while avoiding any bot detection by Microsoft. That way, I can let the program run in the background to earn me points while doing other work because there's no way I'm using Bing as a search engine. First, I'm going to log into my rewards account to make a basic list of tasks that I have to automate, and then I'll start setting the code up. What? What is this? I swear literally yesterday the UI was different. That is crazy. I was thinking about starting this project last week, and I would have been so mad if I automated everything just for them to change the layout the next day. At least now I have the reassurance that this UI will be around for a while. I hope. Alright, let me see if there's anything new to earn from. Okay, so there are the streaks at the top. The search streak is easy, I just have to complete a Bing search. The daily set streak needs you to complete 3 tasks, but as far as I'm aware, you can just click on the buttons and it gives you the points. The app streak can't be automated by our desktop program, but I'm not too worried about that. And the visual search requires you to search by image on Bing. Next we have these Explore on Bing cards. So these are a little more complicated. Not only do you have to click on them, but you also have to then search in Bing for whatever they're asking you about. And then there's some that are locked and we can't do them till tomorrow, so we'll have to filter that out. Next up we have the level up activities, which are mostly just streaks for the other tasks. I'm not too worried about them. And we also have the punch cards, but these are usually more complicated and only update once in a while, so I'm going to skip them for now. And finally, we have this keep earning section that has extra ways to earn points. I think for this one, you can just click on the cards too, and it just gives you the points. And you can also earn up to 100 points a day just searching on Bing at 5 points a search. And they used to have this gift box thing and a daily bonus points chest, but I'm not sure if they phased that out, so I'll see if it shows up as we go along. So now that we have that list, we can start to write some of the logic to control the web browser via Selenium. Normally, when you launch a WebDriver instance with Selenium, it provides flags to let the browser know that it's being controlled by automation software. If I run this code as is, you'll see that there's a notice here that says, Microsoft Edge is being controlled by automated test software. And when we go to this bot testing site, it fails the WebDriver detection test. If we add a few flags that hide the automation indicators though, the notice disappears and the test passes. So we've successfully hidden the fact that a script is controlling the browser. This is important so Microsoft can't use the WebDriver indicators to detect our script. Next, we want to use my Edge browser profile so that we can access my rewards account. The WebDriver usually fails to open the browser's main profiles stored in the user's app data directory because these are usually locked by the actual browser application. But we can at least create a local profile directory just for our WebDriver instance and sign in there. And once we add those options and sign in, we can access the rewards dashboard. Next, we want to be able to navigate around the page, but we don't want to be detected as a bot from things like smooth mouse movement or mouse teleportation. Because it's difficult to make our mouse move like a human, I'm going to use the keyboard to navigate around the page instead. And we're going to have to stagger our key presses so that they don't look like a bot making precise inputs. First, I'm going to write a quick script that records me navigating through the site using keys to figure out what a human on the keyboard would look like, and then analyze that data to best determine how to code the automation script. So while I was collecting that data, I noticed that Microsoft Rewards doesn't actually reward the user anything, when they select one of the tasks with the keyboard. Like if I go ahead and click on this card with the Enter key, it doesn't turn green like the rest of them. But if I click it with the mouse, then it'll give me the points for that card. So it looks like I'm actually gonna have to mimic human mouse movement. The data I collected from the key presses isn't useless though, since we'll still need it to simulate a user typing Bing search queries. I could use a library to mimic human mouse movement, but that's no fun, so I'm gonna try and code it up myself. Humans move mouse pointers in curved trajectories, and most programs attempting to mask themselves as humans use Bezier curves to model this, so I'm going to be doing the same. But humans obviously don't move their muscles in mathematically perfect curves. That would be weird. So the trajectory also needs to have several micro jitters along the way to make the movement seem more natural. We can also have the mouse slightly overshoot its target every so often and then immediately correct itself. And finally, we can't be moving the mouse at a constant velocity because that would be a dead giveaway. We could have the Bezier curve handle velocity for us if we treated it as a function of time that returned xy coordinates back, but I want to experiment with having another function modify the time variable first, and we'll use a logistic function to keep it simple. It should basically warp the movement to ramp up the speed in the beginning and then slow down towards the end. Oh, and one more thing. We can calculate the total movement time using Fitz's law, which models human pointing actions, like using the mouse to point at an object on screen, for example. And now that we have all of that down, let's start implementing it. Bezier curves are defined by a set of control points which define the shape of the curve, and for our mouse movement, we'll be using a cubic Bezier curve, which is defined by a set of 4 control points. So to start, we'll define a function that'll return a point on the target mouse path, given the control points defining the path, and a desired point in time. The first and last control points will be the start and end of our trajectory, but what will the other 2 points be? Well, if we visualize a cubic Bezier curve, we can see that in general, the closer the 2 intermediate control points are to the endpoints, the straighter the path becomes. Since we want to keep the mouse path fairly directed towards its target while not being perfectly straight, we can choose the intermediate control points to be somewhere relatively close to the start and end points of the curve. To do this, we'll set up a small pixel radius around the endpoints and choose one random point within that radius around each of the endpoints to be our 2 intermediate points. This will also handle occasional overshooting, because if the third control point falls behind the last point, it'll go a little farther than the target before returning back to complete the trajectory. That knocks 2 things off of our list, so let's move on to micro jitters. I'm not exactly sure how to implement this, but since I really just need random deviations from the curve, I think I'll literally just do that. We'll write a wrapper function that will basically return the perfect curve trajectory, but also add some random deviations at random times on the curve to make the movement seem more natural. And now we can plot a sample trajectory generated by a program to see if everything looks good so far. Okay, that is definitely not what I was expecting. They're pretty unnatural as they're just randomly placed around as position jumps with no path for the mouse to actually get to them. To fix this, we can designate certain intervals of time as distortion zones on the path, and then linearly move to the distorted point and then back onto the curve's trajectory, so it should look more like small spikes on the path. Great! So now we have a mouse trajectory that's curved, distorted, and continuous, so there isn't any weird teleporting or jumping happening. Now we'll just add a logistic function to transform our time variables so the movement speeds up and slows down, and then we'll use Fitz's law to determine what the total time to move should be. The formula for movement time to a target based on Fitz's law is described by this equation, where d is the distance to the center of the target, w is the width of the target, and a and b are constants that we're going to have to derive for our setup. Since we're moving in a 2D space and moving along a curved path, There isn't a great way to measure the width of the target and the direction of movement, so we'll do a cheap approximation and use the average of the width and height of the target element. To determine the constants A and B, I've got a script that'll help me collect data from my own mouse and use linear regression to find the best constant values. It looks like we got some pretty consistent values, so let's add it to the code and run a visualization script. These trajectories look pretty good. I just want to add a few more path distortions. And that looks perfect. Now we just need to connect this to the browser interface, and to start, we'll try clicking some buttons on the rewards homepage. And it works really well. Now that the most difficult part's done, we can create a few utility functions to work with sending realistic key presses using the data we found earlier. So it looks like for the majority of my typing, the delays between keys land between 0.1 and 0.2 seconds, then 0 and 0.1 seconds, and then so on. Ignoring the actual order of the key presses, we can write a function that uses this data to map a list of key presses to the same delay distribution that we observed with me typing. And now, let's just run a quick test. Perfect, it works. Now there's just one last thing to do before we can put it all together. In the Explore on Bing section, Microsoft provides a task which we have to come up with a search query for. Searching with the relevant query on Bing will complete the card and reward us 10 points. The hard part is going to be coming up with the query based on the description, but since I've already got Ollama and a few small models installed on my machine, I'm going to tackle this by feeding the description to an LLM and prompting it to return a related query. We can also use the LLM to gain the normal Bing search points because it can give us a continuous stream of related queries, similar to a user going down a web search rabbit hole on Bing. So I'll just code up a utility function for the search quests and test it with a couple examples, and it seems to work pretty well. And also create a utility for the continuous query stream, which will start based off of a random word from a word list. And that's what it looks like. Now, we're ready to wire everything up. First, we'll tackle the Bing daily set. It's pretty easy, we basically just need to click buttons. Next, we can do the search tasks using our LLM utilities. And we can also perform a Bing visual search by uploading an image from my computer. Clicking through the miscellaneous cards for points should be easy enough, and we can use our LLM again to complete 20 Bing searches for 100 points. And finally, we can claim our bonus points on the rewards dashboard. And now, for the moment we've all been waiting for. If you'd like to view the source code for this project, it will be available on GitHub, link in the description. I hope you enjoyed this video. Let me know your ideas and any suggestions you might have in the comments. Thanks for watching, and I'll see you in the next one.